Hello everyone, welcome back to intelKeen Skills. This is day 15 of our 30 days code challenge and today we're going to learn linked lists in Python. What is a linked list? It is a linear data structure. It is a linear data structure just like an array. But the way data is stored is different. Here each element in the linked list is called a node. In a node, we have two parts, first part and the second part. The first part is the data part and the second part is the next part. Okay, in data part we'll store the value and in next part we'll store the pointer that points to the next node, means it is a reference, means the pointer which points to the next node. The next node. Okay, now unlike arrays, linked lists do not store elements in a continuous memory. It can grow or shrink dynamically. So these are very useful when frequent insertions and deletions were needed. Means if you want to add any node into the linked list after creation, it will expand the memory dynamically and it will assign that memory to the particular node that you wanted to add. In the same way, if you want to delete the node from a linked list, it will delete the memory, means it will shrink and it will delete that particular node from the linked list. That is what happens in the linked list unlike arrays. Here, think of a linked list is like a treasure hunt. Each clue tells you where the next clue is. Means this is the clue you have initially, which is head. Head means the first node in a linked list. And this is the tail, the last node in the linked list. Last node. Okay. And here you only know the first clue, which is head. This is the only thing you know. And from there you keep moving using pointers. By using these pointers you will keep moving till you reach to the destination. Got it? So there is no index like arrays in the linked list. Now let's see some basic node example. See, let's create the class node. In that class, start a constructor def init self comma data. And as I told you, there are two parts in a node. First part is data part, is equals to store some data to that, and the second part is next part. Initially the next part will be none. Okay, and create an object by taking that class and store the value to it. Now try to print that. Just guess what output we are going to get now. Are you thinking we'll get the output 10 there? No, not at all. Check the output. See, this is the address of this particular node. Okay, of the node you created. This is the address of the node you created. If you want to print the value in that node, for that print node.data. Let's run the code again. See, this is the data that you have in that node and this is the pointer of that node, address of that node. And if you want to check the next, means the pointer in that particular node, means the pointer to the next node, for that print node dot next. We'll have none because no other node is linked to this node in the linked list. Now let's add some more elements in this linked list. Node 1 is equals to node of 20. Okay, we stored a value in node 1. Now we need to link the node and node 1. For that, node dot next is equals to, we'll store the address of the node 1. Address of the node 1 will present at node 1, right? So node 1. Got it? Now let's run the code and check the output. See, this is the address of the first node and this is the value in the first node, and this is the address of the second node which the first node is pointing to. Got it? Now let's see how the traversing happens in a linked list. Traversing in a linked list. Okay, here the first thing is create a temporary variable named current and assign the first node to that current. First node means the object node, right? First node means head, and which is the object node. Current is equals to node, and then start a while loop. While current is not none means check whether there are nodes in the linked list or not. If there are nodes, then print current dot data. Okay, and for the space separation, take AND operator and give space. And again increase the current value, means increase means shift the current to current dot next, so that it will go to the next node. Okay, now let's check the output. See, 10, 20. This is how you can traverse in a linked list. Now let's see how can we insert a node at the beginning in a linked list, and then how can we insert a node at the ending in a linked list. Now let's create a function to insert a node at the beginning. Def insert at head. Okay, here head comma data, and in this function create a new node. New node is equals to same, call that class, and in that node pass the value, means the data, and as it is the head, we are inserting at the head. So in new node dot next, what value do we store? New node dot next is equals to head value, head address. Okay, we are not printing, we are not taking head dot data, we are just taking head, means the address of that particular head. We are storing that head address to new node dot next. Okay, now return new node. Okay, now just copy the same function to traverse and print current is equals to node. Okay, and before that just take the node. Initially we have the head value in node object, right? So take that to head again. Okay, clear? And now call that function which is insert at head and pass the value head comma some value 5. Okay, now here current is equals to not node, as we took that node to head, take head here. Okay, now let's run the code and check the output. See here. So for your understanding, I am commenting out all the print statements here, and comment this and go down. Current.next, and there are no other print statements, right? Let's run the code, and you have to comment this also. Okay, let's run the code. See, this is the output after inserting the value, the node at the beginning of the linked list. Okay, this is how you can insert at the beginning. Got it? What we did here, see, first we created a new node. This is the new node, and this is the head node which is already present in the linked list. We need to add this new node to the beginning of the linked list. So for that, in the new node, we store some value. We stored value 5, and here in new node.next, we are storing the head address. So it will come at the beginning of the linked list. That is what we did. And for traversing and for printing, we wrote the while loop. Okay, I hope you understand. Now let's check how can we insert the element at the ending, means at the tail position in a linked list. For that, create one more function, def insert at tail, insert at tail, at comma data. Okay, and in this function, create a new node. New node is equals to node of that data. And here, as we are trying to insert the node at the ending of the linked list, we no need of again creating new node.next and store some value like that. So leave it off. And here next to that, if check whether there are nodes in the linked list or not. For that, if head is none, okay, return, means if there are no nodes in the linked list, just return the new node. Okay, and out of the if condition, create a temporary variable and store head value to that. Okay, and start a while loop. Here, to insert at the beginning of the linked list, we check whether there are nodes in the linked list or not. But to insert at the tail position, we need to check whether current dot next is not none. See, I'll explain you clearly. See, here this is the new node that we wanted to insert at the tail position, and this is a node that is already present in the linked list. Okay, here we will check head is in the current node for now, which is a temporary variable, and this is the current node. Okay, if while current dot next means this is not none, means some other node is there next to that. Okay, if it is not none, there is some value, some pointer which points to the next node, right? So that is linked to some other node. If it is true, then it will shift to the next node, means current will shift to the current dot next. That is what we will do in this loop. Till when it will shift to that node? Till it will get none. When you got the none value at the tail, then what will you do? You will store the tail into that particular current.next variable. Got it? So let's see that. In this loop, what we are going to do? Current is equals to current.next. We'll go to the next loop. Okay, and here current.next, when that condition becomes false, then we will store current.next is equals to the new node. Okay, and return head. Now head is equals to, call that function insert at tail head comma insert 40. Okay, now repeat the same loop, same traverse function. Okay, I'll write that. Current is equals to head while current in this loop print current.data, and for the space separation and traverse to the next node. Current is equals to current.next. Now let's run the code and check for the output. Somewhere we got syntax error. Let's check that. Yeah, in line 26 we forgot to keep this semicolon. Let's run the code. It is printed twice because we haven't commented down the previous print statement, right? So comment this line, then run the. You got 5, 10, 20, 40. This value is inserted at beginning and this value is inserted at the tail. This is how we can insert the values into the linked list. I hope you understand the concept clearly. Now let's try to solve the HackerRank problem. Let's go there. Yeah, this is our HackerRank problem. A node class is provided for you in editor. This is the class node. A node object has an integer data field which is data, and a node instance pointer next pointing to the another node. A node insert function is also declared in your editor. It has two parameters, a pointer which is head and the data that must be added to the end of the list as a new node object. What is our task? Complete the insert function in your editor so that it creates a new node. First we need to create a new node and insert it at the tail of the linked list, referenced by the head parameter. Just we need to replicate that tail function what we has written in the previous example. Just repeat that. We need to create a new node and we need to insert that to the tail of the linked list. That is it. See here, initially the first line will be the number of inputs that we has to give to the linked list. That is the first input. For suppose, let's take 4. Each of the next t lines contains an integers to insert at the end of the list. And the second output will be that 4 values. For suppose 1, 2, 3, 4, like that. See, I will show that to you. And this is the sample input. They gave 4. These are the 4 values, 2, 3, 4, 1. And this is the sample output. Okay. And see here. Initially we are taking 2 input. And again after 2 we are taking 3. Linking to 3, the second node. The third node 4. The fourth node 1. Like this the insertion has to be happened. The only task that we has to do is just to complete this function. Okay, so let's write it. Here in this function, the same thing. Just create a new node is equals to node of data, and then we'll check whether the head is none or not. If head is none, return new node. Okay, and for traversing, create a temporary variable named current head, store the head value to that current, and check whether current.next is none or not. Current.next is there or not, like that. None, or you can keep is none also. If it is there, current.next is there, then replace the current value with current.next to go to the next node. So after that, when that condition become false, come out of the loop, and in current.next store that new node. Okay, and return head. That is it. Just run the code. Yeah, it went well, and submit the code. All test cases are passed. Yeah, that is all for today. If you find this video helpful, please like and subscribe to intelKeen Skills. Thank you so much. Bye bye.